Okay, so today we're going to be working on changing the way we render stuff in our game. If we look at, let me bring this up here. If we look at how this is done, the default for everything is a sprite, and it's all done based on XY coordinates from the top left corner of the window. And we want to make that a little bit more flexible. It turns out that if we're doing some more interesting UI-based stuff, we're going to need the ability to nest sprites within other sprites, and we're going to need to be able to build up more complex layouts. So we're going to basically completely rewrite what we've got so far. So let's go ahead and get started with that. The first thing I want to do is show how it's sort of set up now. So we have sprite, which is the most simple example, and it implements the drawable interface, which means that it just has a method called draw, which takes a canvas, a paint, and a delta time. The canvas is what we draw on, paint has some information about what we're drawing, and the delta time is how long it's been since the last frame. So if we're doing things like animations or smooth transitions or something like that, we know how far to go into that transition, how much has changed since the last time we've seen it. Independently, so outside of drawable, sprite keeps track of the bitmap that it's drawing, so the actual image that we're trying to put on the screen, the position that it's at, its source rectangle, which is from the image that we've loaded where we're pulling the pixels, the destination rectangle, which is where we're putting the pixels when we draw them, in case the size is different or something like that, and then the frame. The frame is weird. So the frame is sort of like the destination, except for it's translated based on where we're putting it on the screen. So with the destination rectangle, it always starts at 0, 0 and goes to the width and height that we're targeting. The frame is going to start at wherever we put it on the screen, based also around the anchor. So there's this concept of an anchor where we can say that the position of the image, the origin of the image, is going to be the top left, the top middle, the top right, the center, bottom left, bottom middle, bottom right. So for example, if we have a character, like our person here running on the screen, let me bring him back up. So our person here running on the screen, their anchor point is the bottom middle. So when I say that I want that person in the center of the screen, it's going to be, the center of the screen is actually going to be between his 2 feet. Let's change that so we can make him still so he's not running around. So I'm going to come in here to the simulation. I'm going to change his state from running to idle, and I'm going to comment out this code that changes his position. Okay, so now when this loads back up, he's just going to be standing there, and his position is going to be 0, 0 in the world. So world coordinates are based on the center of the screen, and rendering coordinates are based on the top left corner of the screen. So when we say that the simulated version of this character is at 0, 0, that's going to be the absolute center of our screen. And you can see that the center of the screen is in between his 2 feet. So he's standing at 0, 0, and the image is pivoted around the center between his 2 feet. Okay. So inside the drawing, okay, so when we set the anchor, we adjust the position of the sprite here. So we're adjusting the position of the sprite so that when we draw it, we don't have to recalculate that every frame. We're just going to change his position, instantly update that based on where his anchor point is, and then when we go to draw it, we can just use those positions because we've already calculated where they need to be. So we're going to save the canvas, which means anything that the state of the canvas now, we're going to hold on to that. And then we're going to translate the canvas to where we need to draw. Then we're going to do our drawing. Then we're going to restore the canvas back to where it was so that anybody else can draw on the canvas will be in the state that it needs to be in. But then we have some debug renderer stuff, which really should be done before. Well, I guess we're going to change the way that all of this works. We're going to change the way that all of this works. So what we're going to do is we're going to see that a lot of this logic is repeated in a lot of these things. So we're going to pull that out into a common parent class. And we're going to add a little bit more complexity so that we can nest these views up. So we can have a sprite embedded in a sprite embedded in a sprite, and they're all going to be relative to each other. Okay, the first thing I want to do, though, is we're going to start simple. And I'm actually just going to rename this enum from anchor to pivot, because we're going to change the concept a little bit. The pivot point is going to be the point around which we draw the bitmap. And the anchor point is going to be where this image is relative to its parent. So I'm just going to refactor, rename this. I'm going to call it pivot. I'm going to go ahead and let it do the refactor. Okay. I'm also going to add, so we have top left, top middle, top right, center, bottom left, bottom middle, bottom right. I'm going to add center left and center right. So it's centered vertically. Well, I don't like the word center there. Well, we'll just leave it like that. So center left, center right. So it's going to be centered vertically, and then along either the left edge or right edge of the sprite. So we're going to add that. We're going to come to our assets.json. We're going to make sure that, yep, in here we're going to change the name anchor as well. So I'm going to replace anchor in here with pivot. And replace all. And then in our asset loader, we need to find where we're parsing the anchor point. Here. And I'm going to name that pivot. And then here, oh, I guess we have duplicate code here. We need to clean that up. Okay, so here we've changed everything from anchor to pivot. So let's make sure that we haven't broken anything. So nothing, we should have nothing in the simulation service about that, because that's only a rendering concept. Excuse me. Okay, here it loads. Okay. So that was easy enough. So now we have changed anchor to pivot, which is a simple enough fix. So now let's do something a little bit more drastic. I'm going to create a new class, and I'm going to do this up here in render. A new class, and I'm going to call this a movable object. I'm actually going to make this an abstract class because it's going to have some members that I want other classes to implement. It's going to implement the drawable interface. So let's give it, let's do a float, and we're going to call this position. So we're going to have a position. We're going to create a public enums because we're going to bring back the concept of anchor, but it's going to mean something a little different. Anchor, oh, public enum anchor. And it's going to have all the same values as the pivot, because we're going to want to be able to anchor to similar positions in the parent. So we will have a private anchor. So what else do we need? Oh, we're going to need children. So we're going to have just a list of movable object that we're going to call children. So we can iterate through those. Oh, why is this trust anchor? Where did that come from? Okay. So now let's override the draw method. And what we're going to want to do here is we're going to want to save the canvas. Okay. And then we're going to want to translate to whatever position we're in. So we're going to do canvas.translate position.x, position.y. And then we're going to call another method called drawSelf, and we're just going to pass in the canvas, the paint, and the delta time. So this is going to be our abstract method that we need other classes to implement so that we can have them draw their own stuff, and then we can worry about, in this upper level, manipulating the canvas and doing things that are common across all classes. So void drawSelf, this is going to take a canvas, a paint, paint, and a long delta time. Okay, so that's the method that we need then to do. So now, so we've translated the canvas. Well, we saved the canvas, we've translated the canvas to where we want to be. Then we're going to allow whatever is going to implement this class to draw itself. We're going to need the frame here. Let's just do everything in floats. It doesn't really matter. So we're going to have the frame. Right? Yeah. Yep, so now we need to go through the children. So for movable object child in children, the first thing we're going to do is save the canvas again, and then translate to the correct place in the anchor. So let's do switch anchor I really wish Android Studio did multiple cursors. So let's do this in here real quick. Okay. So we're going to say case this, and then I'm going to separate these with curly braces just to keep everything clear, break, and then in here we're going to calculate a x equals something and y equals something. Okay. So before we do this switch, we're going to have to create those. Float x equals 0, y, come on, y equals 0. Okay. Okay. Save live stream after work. It will be saved. Okay. So now we have our x and y, and we need to translate the canvas based on the anchor point of this thing. So if it's top left, the anchor point is just going to be frame dot top and frame dot left. If it's top middle, then the x is going to be frame dot, oh no, I did that backwards, left and top. This is going to be frame dot left plus frame dot width divided by 2. And this is still going to be frame dot top. Top right, again, it's going to be frame dot top. And this is going to be just frame dot right. Center is going to be this. And then this is going to be frame dot top plus frame dot height over 2. Center left, so this is, the y is going to be the same for this. And this one, center right. And this is going to be frame dot left. This is going to be frame dot right. Bottom left, so left and right is going to be the same here. So this is right, this is left, this is middle. So the x's for those should be good. And this should be, if it's bottom left, then this is going to be frame dot bottom. Okay. That should be the same for all of these. Ooh. Okay, so now once we've figured that out, we can call canvas dot translate xy and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate xy, and then we can call child.draw canvas, canvas dot translate paint delta time, and then canvas.restore. And then once we've done all of this, we're going to do a canvas.restore at the end. Okay, so we save the canvas, and then we translate the canvas to our position. So let's say we're starting at the very top. We can think of this like a tree. Let's say we're starting at the root of the tree, which is just going to be the screen. So if we're just on the screen, we'll translate to our position. And then when we call draw self, we're going to draw our sprite, for example, around our own pivot point. Okay. Then we're going to go through our children, and we're going to save this new translated canvas. And then we're going to calculate, whoa. Okay, so when we translate, we're translating from our position to somewhere else. That should be fine. Because our top left can be negative, right? Which is what will happen in our frame. Because now our frame is going to be sort of like the combination of our frame and our destination. No, our frame is just going to be like our dest rect, where it starts at, it can be a negative number. Yeah, so that's fine. That's fine. That should be good. So we'll translate by that, which means that it can even be negative. And then we'll draw our child based on that position. And then if we do that, the first thing our child's going to do is translate to their position. So it's going to be some offset from the correct anchor point in our parent. And then we're going to restore that and restore that. Okay. Let's make rect protected so that we can access it from our children or from our subclasses. Okay, and let's just do the simple case, right? Simple case is sprite. So instead of implementing drawable, we're going to say that it just implements deep copy and it extends movable object. Okay, so now this is going to make me implement the draw self class. And a lot of this is going to be the same. So we don't need to worry about canvas manipulation stuff here because we're doing that all now in the movable object. So all we need to do is this and this. Oh, I didn't copy it. This and this. So all we're going to do is draw our bitmap and then draw some debug information. Okay. So this goes away. We're not, I'm going to comment, no, delete it. Did I? Hold on. Let me make sure that I saved what I worked on yesterday. I did not save what I worked on yesterday. Okay. So let me commit this stuff real quick. So I'm going to commit everything except for movable object, simulation service, Inventory, I don't want to do that because that's what we did today. Renderer. Yeah, this is all stuff we did yesterday. Button bar, button sprite. I don't want to do this one. I don't want to do this one. I don't want to do this one or this one. Okay, so I don't want to do anything in sprite. Asset loader. I don't want to do. Store I want to do. Menu's fine. Inventory is fine. And assets, I just want those. Oh no, actually I want to unstage all of assets and just pick and choose. So I just want this, and that's it. Okay, so this is going to be load inventory from config file. This is what we did yesterday. Commit. Okay, and then this, 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 okay, inventory, yep. Okay, so all of that was rename anchor to pivot. Okay. All right, cool. So now I can just delete this. Oops. Cancel. So now I can just delete this draw method because we're only going to be using draw self. Why? Wait. Oh, we do need this flipped vertical stuff. Flipped vertical and flipped horizontal. So that we can change the facing of our bitmaps. Okay. So we'll get rid of that. The frame, so here when we're doing this, we don't want to do source and dest. We want to do source and frame. And frame is in our parent class, so we can get rid of it here. And here we were just copying dest into frame anyway. So here we're going to say frame is the dest that gets passed in. Oh, but it's a float f or a rect f now. So let's just do this. Okay, so now we have our source, which is where we're pulling out of the image. We have our frame, which is where we're putting the image, and this is going to be relative to its position always. So we can get rid of this here because we're going to be using it from our parent. So let's make the position protected. And let's rename this from anchor to pivot. And we want to rename the setters. Very cool. Okay. So we have our context. We have our bitmap source rectangle. Then our frame rectangle is up in the parent class. We're keeping track of whether we're flipped or not. And then we have our pivot point. Perfect. Okay, so we're defaulting the pivot point to top left and set position. So here's what we're going to do. We're going to change set position to take floats. And we're going to pass, and we're going to do that here in the parent class. So here we're going to have public void set position. It's going to take a float x, float y, not floaty, float y. And here we're going to say position dot set xy. But we need to actually create that. So here, let's create a constructor. Public movable object, and here all we're going to do is position equals new point f, anchor equals top left, frame do we want to, we probably want to take the frame here and not rely on everybody to do it themselves. So here I'm just going to say frame equals frame, and children equals new array list of children. Okay. So that means here, instead of doing this, we're just going to call super, pass that in. Okay, and then we don't need to set position because it will default to that. Okay, so now set pivot still works the same. With set position, let's take in float. And let's annotate this as override. And then here we'll call super dot set position so that our parent class knows where we're going. And then we'll adjust our frame here. Yep, we'll adjust our frame because we know how big our frame is. So let's just save that off. Float width equals frame dot width float height equals frame dot height. And then down here, if it's in the top left, then we will just say frame dot set left is going to be x, top is going to be y, and then right is going to be x plus width. Yep. And bottom is going to be y plus height. Okay, if it's in the middle, top middle, then frame dot set left is going to be x minus width over 2. Top is still going to be y. Right is going to be x plus width over 2. And bottom is going to be y plus height. Top right is going to be top. So left is going to be x minus width. Top is going to be y. Right is going to be x. And bottom is going to be y plus height. Center. So this is going to be x minus width divided by 2. Y minus height divided by 2. X plus width divided by 2. And y plus height divided by 2. Then we have our 2 that we've missed. So we have center left and center right. So let's get those in there. Okay, so this one, frame.set. So if it's center left, so it's going to be on the left edge. So left is going to be x. Y is going to be y minus height over 2. X plus width. And y plus height over 2. For center right, it's going to be, the left is going to be x plus width. Nope, minus width. Y minus height over 2, x, and y plus height over 2. So this part's a bit tedious. So let's just get through this. Frame.set. So if it's bottom left, if it's left, then we just get x, y plus height, x plus width. Nope. Yeah. And then y. Frame.set. Bottom middle, so this is going to be x minus width over 2. Y plus height. X plus width over 2. And y. And then bottom right is going to be x plus width, y plus height. Nope, these should all be minus height. Yep, minus height. X, and that should be minus width too. And then y. Okay, so let's look back through those real quick to see if we've messed anything up. So top left should be x, y, x plus width, x plus height. Okay, middle, so these should be all minus x minus width over 2. Y, still the top, plus width over 2, plus height, right? Top right should be x minus width, and then y, x, y plus height, yeah. Center should be x minus width over 2, y minus height over 2, x plus width over 2, y plus height over 2. Center left, so this should be x height over 2, width plus height over 2. Right should be x minus the whole width, because we're going to go to the right. Center minus height over 2, because we're going to go up halfway. And then x, and then plus height over 2. Bottom left, so we're going to go all the way to the bottom, all the way to the left. So left is x, to the bottom is height y minus height, x plus width, and y. And then bottom middle, minus width over 2, minus height, plus width over 2, and y. And then x minus width, y minus height, and then x, y. Yep, okay, so that looks good. Okay, so we're going to, we can get rid of that now. So we've set the frame for where we're going to draw this stuff. Let's not get x and y. I don't think we're actually going to need that. Get frame. We shouldn't need any more because that's all being taken care of in the movable object. So this flip horizontal stuff. Yeah. Okay, so this is going to be frame.width, frame.height, and frame. Okay. So now deep copy. What are we doing here? Why is this rectf? Let's just make this a rectf. And then we'll just pass this in here so we don't have to mess with it. Okay. Okay, so sprite seems happy now. So we can try to build it and see what broke. So inventory broke. Get frame. All right, let's just add a, do we want to add that? Cell width. So this is the sprite. Why don't we just set the width and the height in the sprite? And then we can get it from there. And then we don't need to do this every time because we know how big it's supposed to be. So here, we'll just set those. And we'll refactor all these. No. Come on, refactor, rename, width, refactor, rename, height, okay. And then we'll add getters and setters for that. Public float, get width, public float, get height, okay, so now here we just want to call get width and get height. Okay. So now this is going to change because we're not going to manipulate the position of this anymore based on the frame. We're just going to set the anchor point. So let's look at how that works. So let me open this up a little more. So in the inventory, we get the background. We set its pivot to center, which is what we want. We also want to set its anchor to center. We don't want to do this. So background.setAnchor. Background is a sprite. Do I not have set anchor? I don't. Okay, so now I'm going to set its anchor to center. And then its position being 0, 0 should work out because it should still be centered around the center of its parent. Cell width, I still need to calculate so I know how to manipulate the cells in there. Add close button. So I'm going to create a new button with this sprite. What? Set anchor. Oh, right. So refactor this to be set pivot. Okay, then we'll worry about that later. So I'm setting the pivot point to be top right because that's where I want to measure this from. I'm also going to set its anchor point, which I need to add the button. Okay. So I'm going to set its anchor to be top right, and then I'm going to set its position. Now I don't have to worry about the size of the header or anything like that because it's going to be in the top right corner, and I just need to move it down by the padding. So that takes an int. So header padding for X. Actually, I want negative header padding and header padding. So it's going to move it left and down by the padding amount. And again, that's a button. So I'll change this to float. Just decided to, so I decided I'm just going to use everything as a float now. I was doing ints for everything, but whatever. Okay, so I'm going to move it down and over by header padding. Okay, for add an item, I'm going to set the pivot to the top left. I'm going to set the anchor to the top left. I'm going to add it to the list. And then I'm going to iterate through and adjust their positions, but I don't need to get their frame. I could just get the... I know how wide this cell is. Oh, but I need to know the width of the... This is just the left and top of the background, which I don't need anymore. I just need to do X is this, and Y is, oops, this, because now it's relative to the image, not to the screen. So I don't have to worry about the position of the image on the screen. This extends movable object. So instead of having a draw, it has a draw self. Which is actually just going to be exactly what this was. Canvas draw color. We're just going to fill the screen with a dimmer sort of panel. We're going to draw the background, which is just a sprite. And then if we have a close button, we're going to draw it. We're going to iterate through and draw the sprites. And then we're going to draw the header text. Okay. Handle click. Okay. So what's this complaining about? Oh, we don't call super? Yep, okay. So what do we need to pass here? We need to pass F00 background dot width background dot height. Okay. We're not using screen config, so we can get rid of that. Simplify things, okay. So let's clean up our imports. Let's look at button, which is broken. So button implements drawable. But it has a sprite. So we're using this as sort of like the decorator pattern. So we have this button, which is meant to be a decorator for a sprite. So it has a sprite and it gives it some additional functionality. Set position, pivot point, anchor, handle click. So really it's this get frame let's come back to this one. So we might actually need to expose the frame for the sprite, but I'd rather see if we can not do that. All right, so let's build and see what's broken now. Okay, so here we have we're initializing our inventory class. It turns out we didn't need the screen config. So this is our inventory loader. Okay. So in inventory, we're already setting our background to be pivot center and anchor center. And so here we're loading, getting our asset manager, getting some information about the header height and stuff like that. We're getting the background image. We're loading that in. Getting the close button and loading that in. Okay, so now the title text. Here is where this is going to be helpful. So we don't need to do this, right? We don't need to get frame center X or any of that stuff. We just need to make sure that our header text, so let's go make sure that happens. So our text object, here, let's move this over here. So instead of implementing drawable, this needs to extend movable object. Okay, and that's going to make us implement that. Cool. So let's organize our imports. So here we don't really have a frame yet, right? Because we don't know how big this is, because we don't know what font we're using, we don't know what scale it's at, we don't know what text size we have, so we don't really know any of that stuff. So here, let's just do the, man. So I'm going to do this. I'm going to say to do. So I'm going to maybe add another constructor. To movable object that doesn't take a rank. Another default constructor. But for now, we're just going to fake it and do super new recdef, because we're going to have to kind of fake it a little bit with this. So here we're going to have to adjust the rect frame. So let's think this through. So frame in this case is going to have to be we're going to have to calculate it here. So we're going to calculate it based on the stuff we set in the paint. So we're going to have to get the old stuff. So old text size, color doesn't really matter so much. Let's just do it all up front. The old typeface. Okay, so then we're going to calculate the size of this thing. So we have the bounds here. And let's not use their alignment stuff. So if we've set left alignment, then float top left. If we've set left alignment, then our left equals 0, because we're not going to change where it is. If we set center, then our left is going to be bounds dot center x. And left is going to be bounds. No, let's not do that. Let's say if it's left, then it's going to be bounds dot width over 2. That's an int, so let's make that 2f. And this is just going to be bounds dot width. Top. So we're not going to take into account position, because do we have position here? We shouldn't have position, because that's an movable object now. Everything else looks okay. So top is going to be bounds plus height. Top is going to be, and we're not going to round this anymore because we're using floats. And in this case, top is going to be 0. And the reason here is because by default, just 0. By default, text in Java Canvas is aligned with the bottom. So if we already want to align with the bottom, we don't change anything. So now, once we figure all that out, we're going to call super dot, well, we're going to update our frame dot set left top bounds dot width. So it's going to be left plus bounds dot width and top plus bounds dot height. And then we're going to call super dot draw canvas paint delta time. Left might not have been initialized. So let's do this. Let's make that the default then. Okay. So we're going to set the frame and then call super.draw, and then that's going to call into us, and then we're going to restore all the paint stuff, and then down here in draw self we're just going to draw the text, and this is going to be frame.left frame.top. Okay, yeah, position doesn't exist anymore. Okay. Right, okay, so we did that so we could do this. So now we don't have to do that. So the text should take a position. Well, let's not do that. Let's just do this, right? So it doesn't take position anymore. So over here, oops, it doesn't take a position anymore. We just set the text, and then by default the position is 0, and then we can say header text dot set anchor top middle. So it's positioned at the top and it's centered horizontally. Header text dot set position. I don't want it to move any in X and Y, but I want it to come down by header padding. Nope, I want header height over 2. What's header height? Header height, it's an int again. So I'm gonna stop using, I'm gonna use floats for screen positions because it doesn't really matter. Okay. Header height, float, float, float. Okay. So now we've set the text anchor in position. So it's going to be halfway down the header height and across. Okay, so let's see what's broken still. Lossy conversion to int. Add items X. Cell width and cell height should also be floats, and we will not round them. Now background get width is a float, so we don't need to cast this. Okay. So here we still have the get frame problem. So here dest is a rect in asset loader, and it wants a rect f. So we'll just make it a recdef. Okay. So this is going to be frame now. Okay, so now these are the only two we have left. Do we want to expose the frame of the sprite? See, initially I thought about making button like a subclass of sprite, but if I made it a subclass of sprite, then you couldn't have animated buttons, because animated sprite extends sprite, right? So if button extended sprite, then you couldn't have animations in there. So that's why I went with a decorator pattern, so that you could have any kind of sprite you wanted as a button. You know what? Whatever. It's not really worth worrying about now. I'm just going to extend, I'm just going to add a method to button, or to sprite, to return the frame. Now let's see if somebody's using that. I'm sure somebody's using that. Yep. All right. So let's just do that. Put that back and change it to recdef. Okay, build. Lossy conversion from float to int. Button bar. Button bar is now a movable object. Oh, extends. So this just needs to be recdef, and this is going to be super. Get rid of this here. Come down here. Button handle click. So button handle click should be float. Float. Well, built. Let's push to the device and see what happens. Let's bring the phone up over here. So there's no way that this all just works right out of the gate. That's so much stuff to change that there's no way it's just going to happen. So what we're going to do is we're going to push it, and we're going to look at what happened, and we're going to go through and do, yeah, see, look at that. Okay, so the background looks right. and that's a sprite. So the single sprite background looks right. Look at the break guy. Okay, so the background looks right. The store button is there. Ooh, and that's way off. Okay, lots of stuff. Lots of stuff to fix. All right, let's start out by looking at the animated sprite there and see what happened to that dude. So this we don't have anymore. Bitmap. Oh, no. So the weird thing with this is that, like, we need to trick the sprite into thinking that it's a different size that it actually is. Yeah, see, we're calling the wrong super here. Update source rect and update frame. Let's see what those do. So update frame. Actually, this should be. Okay. So update frame source rect. Trick the superclass into thinking the image is just the size of a single frame. So this is stupidly named because the update source rect method changes the frame and the update frame method changes the source rect. So first of all, that's weird. I think it's because I was thinking that this was like a frame of animation. So the source is going to set. So this looks like it's actually, I mean, if we look at, let's run this again. If we look at what's going on here, it looks like it's correctly pulling the frame of animation in, but that the place, how it's getting put on the screen is wrong, because the animation looks decently smooth. You can see the person in that little idle animation rocking back and forth, but he's extremely wide. See, so it looks like, I mean, it's a little jittery, but it looks like the animation is happening correctly. So I'm inclined to think update frame is working, but update source rect is not. So update source rect. And we don't need to set position 0 because that's going to be the default. Maybe that's what was messing it up. Set position. No, that just changes the position. We're just translating the canvas. So in here we get a frame and we just save that frame. And then we just use that frame forever to do stuff. And inside movable object, we don't change the frame. Okay. In bitmap, or in sprite, so here we're going to come into animated sprite. And we're going to call super, which is going to create it based on the frame stuff. which I don't know why we're doing that. We have, right away we have the information to start. So why don't we just change how we're doing that? So here we're gonna say rect source equals new rect, and actually let's do this. Animation information. So we have a okay. So this is the wrong place. So this is just a single animated sprite. Okay, so we're looking at the wrong thing. What we want is this. Oh, I've closed it down, haven't I? We want this multiple animation sprite. So this extends animated sprite, or it sets the animation information for the default animation, which is correct. And then when it chooses to play a certain animation, it finds that, sets the start time, sets the current frame, gets the animation information, and sets the chosen animation to that, then calls update source rect, which should be fine. Okay, so no, this is the right place. So here we're going to say that our source rect equals new rect, and we're going to get animation information, frame start. We're going to get the, why is it a 2D array? Oh, multiple frames and then XY. So frame 0, X, frame start, animation 0, Y. You know what? I'm just going to make this better. Int X equals this. Int Y equals this. Oh my gosh. And then here, our source rect is going to be X, Y, animation dot width, X plus animation dot width, and Y plus animation dot frame height. So that's our source. And then our destination is going to be a rect F and that's just going to be 0, 0, width, animation dot frame height. And I should be able to put these in here. Source, dest. Why does not like that? So I want super to be the first thing called in the constructor. Which sucks, but we can do this. It's going to be ugly, ugly. Is that basically what I'm doing here, though? Oh, no, I'm getting the whole bitmap width. Okay, well, it's going to be gross, but we're going to do it. Okay, so this is the source rect. Nope. Okay. And the destination rect. And let's see what that does. Okay, so now he's the right size, but he's in the wrong place, which is a good start. Okay. So now we can look into the movable object stuff. Okay, so let's go to our renderer. And set a breakpoint here and debug this. So he is just in the world. So his, oh. Okay. So with him, he's in the center of the simulated world, which is offset from see this transform position takes the screen position and adjusts it. So we don't need this anymore. Well, let's step into it. Let's step into it and see what's going on before we get too super excited. Debug. So let's step into here. We're going to come into draw. Oh. Okay, well that's a bug. So we don't want to override draw anymore. We want to override draw self. And animate it there. Okay. I mean, that shouldn't... No. Oh, and this needs to be draw self. Stop building. Oh, too late. Okay. So this needs to be draw self, because that's just handling the drawing, and then the movable object stuff is going to handle everything else. So draw self. Animation, so it's updating which frame we're on, and it's updating the frame, which is still a stupid name, and then we're calling super draw self. Ooh. So we're still in that lower corner down there. Okay, but now we can debug this, and we should get taken into the movable object draw method, which will then forward it on. Okay. So here we're going to step in, and we go into movable object, which is good. So we're going to save the canvas. Position is 540 and 852. 540 and 852, which seems right based on this screen, because it's 1080 wide. Okay. So we're going to step into draw self. Step over, so we're updating what frame of the animation we're showing. And then we're going to step into draw self here. If the person is flipped, what's our source? And our frame that looks reasonable to me. So the left is 464 to 616. And the top is 595 to 852. But that puts him down there. Okay, let's make sure I'm thinking of this correctly. So let's stop our renderer. Let's come up here where we get our screen config and put a breakpoint. Okay, so our screen size, yeah, it's 1080 by 1704. Okay, so let's come down here. So it is 1080 wide. Let's put a breakpoint here and run to that. So we get our very first game state. We pull our character out of there. And they have a position of 0, 0. And they are idle. So when we transform that position, step out, step in. So we get our sprite, and we get our position. What's our sprite anchor point? Oh, what's our sprite anchor point? Yep. Anchor is top left. And the pivot is bottom middle. Okay. So what else have we drawn when we're rendering this? So on draw, we draw the background. All right, so let's so we draw the background and then we draw him and that's it. So let's run this. Okay, so there he is down there. So when you draw the background, we should step into the movable object stuff. The anchor point should be top left. Top left. Its position should be 0, 0. It is, so we're not going to translate the canvas at all. We're going to draw self. And it's not going to be flipped or any of this stuff. Okay, so we're just going to draw it from source, which is full screen size, to dest, which is full screen size. And then we restore the canvas. So it should not be translated anymore. Oh, it never was translated, right? So then we step into the game world. We get this, and we draw it. Okay, let's try this. Let's say because of how we translate from the simulation to the rendering, pivot, before we set it in there, let's just say that, let's just by default when we load them in, canvas changed. That his anchor point is center. So we fixed that in our asset loader, right? Asset loader. Pivot, set pivot, yeah. Okay. No, cancel. So if we set them to be offset from the center, then when we transform this position, we don't need to worry about the origin. We can just set X and Y. And that didn't work at all. Set position. So where is he now? So for the top level object, we're not taking into account their anchor position. Right? Because I said center, but there's nothing actually making sure he gets centered. So x is 0 and y is 0, which should be correct. And then when we go to draw him, though, there's nothing to translate him to the center of his parent, because he doesn't have a parent. Okay, that makes sense. That makes sense. So I'm just going to do this. Before I render the game world, I'm going to save the canvas. I'm going to translate to origin.x. Nope, origin.y. And then I'm going to restore the canvas. So that way, everything in the game world is based off the center, and everything in the UI is based off the top left. Hey, there he is. Okay. So now I should be able to put the code back in the simulation. They would have him walk back and forth and change his state to running. And now he should go to the edge of the screen back and forth on both sides just like he was. Nope. Andy looks skewed. Oh. It's the flipping code. Sprite. If flipped, we're not going to translate the canvas, are we? What happens if we just scale it? No, but I mean, that makes sense. So we want to translate the canvas by the height of the, oops, by the width of the person. Okay, so let's stop him running. And just try to flip him and see what happens. So let's do this. So we're gonna change him back to idle. And it says facing the left. We're gonna comment the rest of this stuff out. And see if he is flipped appropriately. Because we should, I mean, if we look at the sprite code, we want to move the frame by the width of the image and then near it, so we scale it the other way. So look at that. So he is scaled the other way. But he's moved over. Is that because of his pivot point? Is that because of his pivot point? Is that because of his pivot point? What if we say that instead of doing it around frame.width, we're going to move him over frame.centerX? Because then that should always be right. Because it wouldn't matter where their pivot point is then. If we adjust the frame and we pivot around the center, yay, there we go. Okay, so let's do the same thing here. Center Y. Okay. And now let's not get too super excited until we try to move them. So here I'm just going to set his position real quick. Current wibble.set position. I'm going to set his X position to, like, I don't know, 100. His Y position is 0. And we'll see if he moves what seems to be 100 pixels. Actually, you know what? So it's 320 by 480. So half of 320 is 150, 160. So I'm going to set his position to 160, and he should be on that edge there. So let's do that. So if this is correct, then he should be on the rightmost edge of the screen, and then I can make it negative 160 to make sure he goes to the leftmost edge. So the reason it's 160 is because in order to handle multiple screen resolutions, I have a world that is 2 by 3, and it's 320 by 480 sort of like logical pixels. So sweet, so he's over there, that we can then map to whatever the size of the screen is. Let's see if this instant run stuff works. So we can map that to whatever the size of the screen is, so that we're not, nope, garbage. Okay. So that we don't have to worry about compensating for that, right? Okay. And there he is on the left side of the screen. Perfect. So now let's try top and bottom. So it should be negative, let's do positive first. So 480, so it should be 240. And he should be at the bottom. And then if we do negative 240, he'll be at the top of the simulated world, so you can see what the edges of those are. I have a little debug thing that will show that area on the screen too, so we can see what that looks like. Nope. Okay. So that didn't work. So let's see where he's gone. Let's go to the renderer. Well, we should already have breakpoints in there, so let's just run this and see what happened. Okay, so we get this position, and the position is what we expect. So we're going to transform that position. So let's see what that does. So that gives us an x of negative 540. And a y of 810. Oh, no, that's good. That's good, because it's from... Right. It's offset from the center of the screen. Okay, so negative 540 makes total sense. Okay, 810 offset from the edge of the screen should also be okay. Because the screen was like 1707. So if the screen is 1707 divided by 2 minus 810, yeah, so that should still give us about 43 pixels from the bottom of the screen. Okay, so that seems reasonable. So here we're just going to change, so we're flipping them horizontally, because we don't do vertically yet. So let's step into here. We're going to translate from where we are to his position. And we should have been in the middle of the screen, so that should be fine. When we go to draw him, we're going to update the animation and then try to draw him. So he is flipped. So we're translating a little bit over and scaling by -1. And then we're going to draw the bitmap. So what frame have we got now? What now? Bottom is 810. Left Yeah. And top is that. That seems reasonable. So where'd he go? Let's do it again at 0 and just see what happens with that. Because I saw him there on the left-hand side, right? Yeah, so he's there on the left-hand side. What if we just move him down like 100 pixels? Oh, wait, no. Was he up top and I was just missing him? No. Whoa. Why is 100 pixels down there? That's roughly where I would expect the boundary to be. That's where I would expect the edge of the world to be. Here, let's just comment this out for now. And I mean, we should be able to draw that box. Yeah, that's all messed up too. Shoot. Alright. So we've got a lot to fix. Okay, so why is moving him 100 pixels moving him so far? So position Y. So I'm creating a ratio of his position to the world size, and I'm multiplying that by half the height of the actual screen size. Oh, I wonder if that's jacked up. No? That should be okay. Because I mean, it's just a logical frame, so it doesn't matter whether it starts at 0 or not. It should still give us the height. Put a breakpoint there and get rid of these. Okay. So screen config world size is 320 by 480, and game area is 0, 42. I can't remember what order those are in. So the left is 0, the top is 42, the right is 1080, and the bottom is 1662, which makes sense. So if I'm multiplying by half of that, it's Come on now. Give me what I've highlighted here. Okay, we're just going to do it this way. So if I take this and I watch that, so 810 is half the height of the game area, which makes sense. And then Y should be, okay, so that makes sense, right? Because I'm only moving down 100 pixels out of 240, so translating down 337 pixels makes sense. Okay. So when we go to draw this, is there a way to get the current canvas position, I wonder? No, or no. No. So I know 0, 0 put them in the middle, right? So I know I've translated to that. So, here, I save and translate to negative 540, which puts on the left edge of the screen, in 337. And then when I draw self, update, maybe update frame is messed up. Step in. So here, top is 80, which makes sense. Bottom is... So what's going on here, man? So source is that, which is fine. Frame is that. So the left is negative 616. Which is a little weird, right? Because it should be should be 1080 divided by 2, so it should be negative 540. Is that what it was when this was 0? So why was that 6 something? Because it's 1080 wide. Okay. So here, come on now. Position is negative 540, which is what we wanted. So how did that happen? 540. So he's there. So 540 and 0 are the positions that he gets. Okay. So if I change this to just be 10, what happens? Shouldn't affect X at all. It should be 540 and I don't know. Okay, so X is negative 540, okay, and Y is 3375, okay, and there he is. So not far offset from the center. Okay, so let's bump it back up to 100. So now, yeah, it's still negative 540. And, okay, so that's reasonable. So where's it going off the rails? Step in here. I didn't step into draw self. Okay, so that looks good. Step into draw self. Oh. Okay, that makes sense. Because that's his center position. Okay. So that makes sense, right? Because that's the edge of his bitmap. So his center is negative 540, but his left is negative 616, which is fine, because he should hang off the edge of the screen a little bit. And he's down there. Oh, but that's not where he should be, though. He should be not that far down. Because 240... All right. So his starting position is negative 160 and 100. And the X seems to be working fine. The Y is where we run into issues. But it's the same sort of calculation. I take the world size, Y, which is 480, over 240, and I find the ratio of his position into that. And then I multiply that by half the screen height. Half the game area height. In this case, the game area height, so it starts at 42 and goes to 1660. Is 1618. So if I divide that by 2, 809 should be all the way down. But we're getting 337 is almost all the way down. Okay. Let's try this the other way. What happens if we try to move them up? I should be able to move them up 100 and see what happens there. Is it like a weird scaling thing? Is the canvas scaled? Somehow? No, so moving them up 100 does the same thing. Okay, something weird is going on. So let's do this. Before we do any of this stuff, we get the canvas, get the game state. Before we draw anything, I'm going to say canvas dot there's got to be a, I mean, restore, but restore only takes you back to a save point. So let's go to the documentation here. This call balances a previous call to save. It is used to remove all modifications to the matrix / clip state since the last save call. It is an error to call restore more times than save was called. Okay. Are we doing that? So let's see if we're doing that. So here we say save. Well, are we not restoring where we saved somewhere? So here we're saying save and restore. So we're going to save, translate, draw the game world, and restore. So in the game world, transform position, doesn't actually move the canvas. And we draw this, and that doesn't, we don't change the canvas outside of here. So let's see, inside of movable object, the first thing we do is save the canvas, and then we restore the canvas. And here we translate to the position. Yep, translate to the position and draw self. So that's going to be animated sprite. So here we don't mess with the canvas, and then we just go to sprite, draw. Over here we do mess with the canvas. So let's do this. Let's say canvas.save. Canvas.restore. So before we change anything, we're going to save it, and then we're going to do possibly our stuff. And then we're going to do our drawing, and then we're going to restore it. But that shouldn't matter, because I think in theory, that should have been taken care of here, right? But still, we manipulate the canvas, so we should reset it. because all this stuff is going to get skipped. So it should just restore right there. So it shouldn't change anything. And yet there he is. Well, it's time for me to break for lunch. And then I have some errands to run, so I'm going to keep working on this and try to figure out what was wrong. And we will have to regroup later. So thank you for those of you who are watching. I will do another stream where I will report back as to what I found, and hopefully we can get this sorted out.